Hello statistics student, this video is for chapter 9.5 part 1, discussion of full hypothesis test for population proportion. So in the previous lesson we did 9.1, 3 and 4 to go through the basic of an hypothesis test. Mainly you need to write the hypothesis, you need to do some calculation to find p-value, which investigate how your sample is it a rare sample or is it a non-significant sample, and then you do a conclusion. So but it is a very high level way of just looking at the thing. Primarily we are practicing writing the hypothesis and also writing the conclusion. Now we're going to do the whole thing but concentrating on testing for population proportion. So whenever we are testing for percentage of a category, it is a test for proportion. So some term first. When we do binomial distribution, we say X is the number of success and N is the population or the sample size. Now proportion would be, sample proportion would be in this sample, what is the percentage of success, and we call that p hat. This book use p prime to do it, so there are some books that do that. So that is also another convention for denoting sample proportion. The actual population proportion is just p, okay, and it is the one that you are trying to test for the claim. And there is another parameter called q, which is the proportion of failure. That means it's not p, it's 1 minus q. 1 minus p. Q is 1 minus p. And likewise, you can have q hat equal to, in the sample that is the sample failure is 1 minus p hat. And then we also have alpha is significant level, which is the probability of unlikely. You can determine what you want to be, or by default is 0.05. So let's go through the step first. We would expand the step of finding the test statistics and p-value in details, and also talk about how to find them in detail. And for the other one, it would be whatever that we have done before. So the writing the hypothesis. So these are the one that you are familiarized with, and also writing conclusion. But in the conclusion step, I split it into 2 steps. Okay, so it is 6 steps. First, you write the claim, the null hypothesis and alternative hypothesis in symbolic form. Remember, the null hypothesis needs to be p equal to a particular value. The alternative would be either the claim or not equal. Okay, and then before you do that, you also identify the number of success and failure in your sample. N and X are above sample. N is sample size. Then number 2 is to identify significant level, what types of tests you're doing because you are ready to put in the calculator, and also the sampling distribution of p hat, which is always normal for p hat. The third step is the major thing that we add for calculating p-value and test statistic z. So the way to do it is statdis.com. So I'm going to show you here. So here, this is statdis. You go to analysis, not confidence interval, hypothesis testing, and we're doing proportion. So proportion one sample. So basically you click on that and you will add so what you do is you will, oops, sorry, I need to move this around. Yeah, so you would input this. The first box is to figure out what the alternative hypothesis is. It's very easily forgot because it seems like it is the title, but it's actually not. The very first things you do is the alternative hypothesis. You input the significant level, you input proportion, claim proportion, and you input sample size and the number of success, and then you hit evaluate. You would be given, there's a lot of things that they tell you. First is you have to check that your alternative hypothesis match yours, and then they do give you the sample proportion, which is X over N. Then we don't use it as much, but we would use a test statistic Z and also p-value. These 2 are the one that we use. We don't use a confidence interval. We don't use critical value. Critical value is used for doing hypothesis tests using the critical value method. You can see that in the result there is a plot. They actually plot to you as to where your sample is. Your sample is the blue line, and then where the critical values are. That means according to X0, these two are the, kind of the mark, the threshold where we would say, oh, this sample is unlikely. Okay, so we can look at these. But primarily, the main thing that we want is p-value. So let's go back to our notes. But basically, in all of these, that's what you do. So this is step 3. That's the calculation. You will need to get a test statistic Z and p-value. And then the next 2 steps are making conclusion. To make a conclusion about the null hypothesis X0, if the p-value is lower than alpha, then you reject X0. That means the sample is significant. It's a rare sample. You're very surprised. Not because you did something wrong. It's because according to the null hypothesis, you're not supposed to get that sample. There must be something wrong with the hypothesis, so you rejected it. But if p-value is greater than alpha, this is a, expected sample that's go in line with X0, so you say you fail to reject X0. And then the next thing, the most important thing, is you have to make conclusion about the claim. If you reject the null hypothesis, you have sufficient evidence. If you fail to reject the null hypothesis, then you don't have sufficient evidence. So when do I use the word support or reject? You use support if your claim is the alternative. You use reject if your claim is actually X0. So you have to go back to the top to see where my claim is. A lot of times your claim is the alternative, so you would use the word support. And an alternative of doing this kind of analysis is also you can use the flow chart. So the flow chart is here. You can say if my X0 is the claim or is my H1 the claim. The alternative is the claim. So so either way you would gonna make the conclusion about the claim, and then if there is other inference, you would make some further inference. So that's the basic steps. Now, not every sample can be used to run this hypothesis test. To be able to get the conclusion or use the conclusion for the hypothesis test, there's 3 conditions. So the most important one, of course, is the samples are randomly collected sample. They're not biased sample. The second thing is the number of success or failures are at least 5. Why do we need this condition? Is because it guarantees that p hat is normally distributed. We talked about this a while back when we do a confidence interval. The reason why we can do confidence interval for p hat is because p hat is normally distributed, and one of the condition is n times the expected proportion and n times the expected failure proportion is at least 5. And also, yeah, your X has to be the number of success has obey the binomial requirement. You have 2 outcome and independent sampling, those kind of things. So these are the conditions that is required before you can use the conclusion. So you cannot just go out and get some sample and run the hypothesis and say, oh, I can conclude something. I can support whatever hypothesis. So let's do a first example. So all of the question in this part, 9.5, part 1, is like that. So we just keep on drilling how to do the hypothesis test. So first, example 1, there is a survey of 1,009 customers shows that 545 are uncomfortable with drone deliveries. Do you like to have drone deliver your order? I don't know about laptop. Test the claim that majority of the customer are uncomfortable with drone deliveries. So use alpha equal to 0.05. That means so when we say that majority, that means greater than 50%. More than 50% would amount to a majority. So it is about percentage of customers that are uncomfortable with drone delivery. So it's a proportion. So this is the claim. The claim say that more than 50% are uncomfortable. So we will say the claim is a direct translation. P is greater than 0.5. Then we'll have to write a null hypothesis because we have to do some calculation. It has to be equal. So of course the other one, the opposite of greater than will be less than or equal to. So we'll just pick the highest number of the less than equal to, which is 0.5. So you write it as equal to 0.5 because it's the highest that it can in this particular assumption. And then the alternative hypothesis is exactly what the claim is greater than 0.5. And then you have n equal to 1009 from the question, and x is 545. So this is what you would write down everything. So step 1 is kind of like the preparation step and writing down the claim, setting everything up. Step 2 is to writing down more information. You look at this again, you say, okay, what type of test is it? And also find out if we have significant level. Sometimes you might want to adjust it later on when we know what impact it has. You can adjust it. And then what kind of distribution we use. For proportion is always normal. Okay, so we write this. You have get used to this. You have been doing this since the last section, so it should be not difficult. The third step is actually the calculation. So we are doing a hypothesis test for proportion, P for proportion. And then our test is a rate tail test. So what we'll do is we'll switch to statistics. And our significance is 0.05. We are doing greater than, right? You click greater than. And then you will say is 1009. What was the number? X545. So 545. Oh, the claim proportion is greater than what? Greater than 0.5. So this is a little difficult. It would be easier if the box is here, but they would say population proportion greater than 0.5. And it's 545 for X. And after you fill everything, you would evaluate. So then you would read off Z is 2.55, p-value is 0.00539. You round it to 0.054. Test statistic is 255. This means that your sample is 2.55 standard deviation from the mean of p equal to 0.5. And if p equal to 0.5 is true, this sample has a probability of happening at less than 1%. So obviously step 4, you will say this is a rare sample, so I should reject the null hypothesis, and you conclude that you have a significant sample. You have enough evidence. You have sufficient evidence. So sufficient evidence, what should I do? My claim is here. I'm rejecting this, so I would be supporting the claim. Support the claim because the claim is X0. So there is sufficient evidence to support the claim that majority of customers are uncomfortable with drone delivery. So we can also use flowchart. So right now I'm just using the fact that whenever I have low p-value, I use sufficient evidence. And whenever I have HA, I use the term support. Now it's not 100% that you support, but I use the word support. So sufficient evidence to support. You can also use the flowchart to say, okay, my claim is alternative hypothesis. So I look at this box, I look at 3 and 4. I reject the null hypothesis, so I say the sample data support the claim. So this box number 3. So if you want to, you can use the flowchart or you can just analyze your results. The last part is, should a company start to invest in drone delivery now? Now, they say that most people are uncomfortable with this, so there's no need. There's no rush to invest in it. Okay, so this is kind of like the further conclusion that you can make as a result of the hypothesis test. Okay, so we'll do, we have 2 more examples. So we'll do it in the next video.